Today we're going to talk about steel construction blueprint reading. We're going to talk about how the beams are laid out, and so you have a better understanding of them. First of all, a beam has a flange, a web, and a flange to make up the beam. If we're talking about a W12 of 14, that means it's approximately 12 inches from the bottom to the top of the flange, and every foot weighs 14 pounds. This particular one, W12, the depth is 11 7/8. The web is 3/16 thick. You have an unworkable zone with this little curve in your beam. It's called a fillet. You're not allowed to put no welds in there, nothing. And this one here is 3/4 inch from the top of the flange to the bottom of the curve, and then that's like your unworkable zone. You have a workable area, a working area is between the two unworkable areas. Your flange thickness is 1.25 inches, and your flange width is going to be 4 inches. You find this in the steel construction manual. You find this information. You look up the W12, find W12, and then you find where it says 14, and then it'll show you the information that you're needed to lay out this particular beam if it fits what you need to be done. We're going to talk about the beam itself here. First thing we're talking about is when you have a measurement, if you have holes in the web, remember the web is over here. You have a running dimension of 11 feet. That is from the furthest point out. RD means running dimension, and it's from the furthest point of what you're working and what you're building. So in this particular case, we have a W3 sitting here, and it sticks out past the beam, so that's our running dimension. So from that point to this first hole is going to be 11 feet. Again, you have one arrow here, so and it's marked 13 feet. So from the running dimension to the next hole is going to be 13 feet. We're going to talk about the angle that's sitting on there. Everything's done in abbreviations. There are two angles, W3, 4 inches center to center. So it means there's one, as you can see, and the one on the back side. What they're telling you here is there's 3 holes in it, 1, 2, 3. And then they're telling you also that there's 4 inches from center from one angle to the next. If you look down here, the typical angle here is a W3 laid out, 3 inches from hole to hole. And when the particular piece is 8.5 inches long, you have 1.25 inches to the first hole, 3 inches to the second, 3 inches to the third hole, which leaves another 1.25 inches. On the prints, they'll just show you the 2 3s, and you'll have to do the math and figure out it's 1.25 inches from each side, so you equal 8.5 inches. The holes are slotted 13/16 by 1, 1 and 13/16 from the bottom of the angle to the hole, to the center of the hole. The 4 inches here from center to center, C, is from the center of that hole to the center of that hole. You want to try to hold 4 inches. On the outstanding leg, OSL, this is what the leg's coming up off the beam, is your outstanding leg. We know it's going to be 1 and 13/16 to the whole center of the hole. Remember, they're slotted. And they're slotted in case this particular piece isn't thick enough for the hold to 4 inches. So if this particular piece is 1 and 13, we'd add that twice, get 2 and 26/16, round that down to 3 and 10/16, which is 3 and 5/8. We're trying to hold 4 inches from here to here, so you take 4 inches minus 3 and 5/8, you got 3/8, what the thickness of that web should be. Now that can be about, because remember we slotted the holes, so if that's anywhere from 3/16 to 3/8, that the holes will still fit. We also have in here, I marked that I found in layout of this particular beam. And remember, beams run horizontal with a land. And here's the print. We have a W12 of 14, 22 feet, 10.5 inches long. You can also find that in the parts print. The parts print is over and on the same print, always off to the right. Here's 99B2. There's your W12 of 14, 22 foot, 10.5. Now, you see this 22 foot, 11 and 11/16? That's out to out. So from the outside of that clip to the outside of that clip, they're holding 22 feet, 11 and 11/16. Or we'll show you another example. We'll go to the next one, 99B6, which is straight across. We got W12 14, it's 22 foot 10 and a half again. And here they're holding 22 feet 11 and 3/4 at the out to out. So they're holding this here a ½ inch out here, and so the remainder to make up that distance will be held over here. Another example here, you got same kind of beam, W12 of 14. Remember the W12 is the height from the flange to the bottom of the flange. 14 weighs 14 pounds per foot. And you've got 22 feet, 10 and a half inches long. But now they want the out to out, same as the one before. Here's the ½ inch, so the remainder comes off to the other side. Over here, they're also showing you the W3. You need 8 of these beams. So there's W3, they need 36 W3s because they're on both sides of the beam, near side and far side. It's an angle, it's 3 by 3, and it's 5/16 thick, and it's 8.5 inches long. So if they don't tell you over here about how to lay that out, this is 2 angles, W3, gauge outstanding leg, 1 13/16. The holes from one W3 to the next W3 is 4 inches center to center, and the holes are 13/16 by 1, and they're slotted in the outstanding leg. Again, that's here the OSL. If you look up to the top here, they have a notch in it. So it says cut 3/4 by 2. You notice that the 2 is inside of the 2 lines, extension lines. So it's going to be 2 inches in length, and it's going to be 3/4 inches drop down, 1 3/4 inches, I'm sorry. Yep, it is 3/4 inches that drop down for the cut. If anytime you see a cloud inside of a print, it's basically telling you that it's not as typical as the other ones. In this particular instance, it's on the slope, 12 by 8, and the clip is being sloped or slanted, so it was a degree. So that's why they have that cloud and showing you that that's the purpose of that.